Alright, 2.7 graphing inequalities. Students will be able to graph linear inequalities and absolute value inequalities. So the trick with these guys is that you just graph this like a line first, okay? But you need to know that if it has an equal sign or equal to sign, then that means it's a solid line. If it does not, if it's just greater than or less than, then when you graph your line, it should be dotted, okay? That's the first step. Now, let's graph this line. Well, this just looks like 2x plus 1. So let's go up 1, and then I go up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1, so on. And like I said, it has an or equal to sign. So that means that my line is solid. Okay. Now, the only other part is I'm going to shade one side of this graph. Well, y is less than. Y goes up and down. So if y is less, wouldn't that mean y is underneath? So you shade underneath. That's all there is to it. So why don't you try practice number 1. Graph the line and then shade a side. I'll put the answer up in just a second. Okay, so the first step here was to just graph a line, right? So we went up 2, down 2 over 3, down 2 over 3, down 2 over 3. Now when I actually drew the line, it had to be dotted because it's not equal. So I just draw a little dashed line. And y is greater than, so that means I'm going to shade above. Y is greater than, I shade up. When it's less than, I shade down. Okay, let's try a different one here. This one's going to be a little bit tricky because it's in standard form, and the slope's going to be kind of weird. The y-intercept, the x-intercept is going to be kind of like fractions. So we're actually gonna find the x and y-intercept, but we're going to change the way this graph looks, or the way we talk about this graph, so that it'll be real easy to plot. I'll show you what I mean. First, let's find the x and the y-intercept. X-intercept, cover up the 4y, and we would get 3x is equal to 5. Divide both sides by 3, divide by 3, and we get that the x-intercept is 5/3, which is also 1 2/3. Okay? The next thing we do is we cover up the x, and we get 4y equals 5, divide by 4, divide by 4, and we get that the y-intercept is 5/4, or 1 1/4. Okay. Now, here's the deal. Because my x-intercept is a weird fraction, and my y-intercept is a weird fraction, instead of just making this 1, 2, 3, I can actually change that. I know my x-intercept is in thirds, right? 5/3 to be exact. So what I'm going to do is I'm going to make my x-axis in thirds. Let me show you what I mean. Right here, I'm going to go over 3, and I'm going to call that my 1. Over another 3, call that my 2. Same thing back here, -1, -2. Now my graph is broken into thirds really nicely. So when it comes to plotting 5/3 or 1 2/3, it's really easy to find. It's right there. Okay, same thing with the y. Let's take a look. The y is in fourths, so I'm going to break it into fourths. Go up 4, and let's just call that 1. Up another 4. Let's call that 2. I could do the same thing down here. Because this graph is unlabeled, I can label it however I want, and that's going to make it really easy to graph. So I had 5/4 for the y-intercept, or 1 1/4, right there. And so now all I need to do is connect those two dots, and it would be a solid line, because if you look, remember, it's an or equal sign, so that's a solid line. And now, how do we figure out which side to shade? Well, this is actually pretty simple. If you think about it, we're going to pick a side, a coordinate actually on one side, and plug it in. I think the easiest coordinate to plug in is the coordinate 0, 0, which is right here in the center. So let me show you what I mean. We got 3x plus 4y less than or equal to 5. Let's plug in 0, 0. So 3 times 0 plus 4 times 0 is less than or equal to 5. Now, I'm writing this out, but you probably could just do this in your head, right? Because 3 times 0 is 0, 4 times 0 is 0, add that up and we just get 0 less than or equal to 5. Well, is that true? Is 0 less than or equal to 5? Yes, it is. So that means that this is a solution to this inequality. So that means we're going to have to shade on the same side as 0, 0. So, shade down here. if this was not true, if I got something like 0 is greater than or equal to 5, which we all know is not true, then that would mean that that is not a solution and the other side is. We'd shade over here. So that's how you do that. Okay, let's go on to the next page. Alright, example number 3. A shipping company is hiring seasonal employees to help in their packing and shipping departments. Packing and shipping. Write an inequality to describe the number of employees that can be assigned to each department if the company plans to hire at most 20 new employees. Then graph the inequality. Okay, well, at most means what? If I have 20 total, or 20 at most, that means that whatever my equation or inequality is going to be, it's going to have to be less than or equal to 20, right? So 20 is my maximum that it could be. And then what am I doing? Well, I just have packing and shipping. Well, so packing plus shipping. So my packing employees plus my shipping employees should be less than or equal to 20. There we go. I wrote an inequality. Let's label our graph over here, packing and shipping. And let's ask a couple questions here real quick. Could I have negative shipping employees? Well, no, I couldn't. So I couldn't graph over here. And the same thing, I couldn't have negative packing employees. So my graph is not even going to exist here. It's just going to be at this quadrant. Now, can I find the x and y intercepts really easily? Cover up the p, and I just have s equals 20. Cover up the s, and I just have p equals 20. So my p-intercept and my s-intercept is just going to be 20. So let's graph that. If it's easier for you, I like to maybe make this every 2 digits 5, just so we can fit it on the graph. And I know that I'm going to have to plot right here and right here. And then I just connect that line. Okay. And I know that it doesn't go into the negative, and it doesn't go into the, it doesn't go into the negative s, and it doesn't go into the negative p. So that's it. That's all I'm going to graph is right there. Now, I need to test and see where I'm going to shade. Well, same thing. I'm going to let you guys figure this out. Pick a coordinate on either side and test that in this function. If it's true, shade on that side. If it's not, shade on the other. So go ahead and try that out, see what you come up with. And I'll put the answer up in just a second. Okay, so I pick 0, 0 again because it's really easy. Plug it in. 0 plus 0 is less than 20. Yeah, that's true. So that means I'm going to shade on this side of the graph. But remember, I'm not shading in the negatives because I can't have a negative higher. And we're going to find that a lot of real-life examples only exist in this first quadrant. Now, some exist in these other ones, but most things that we deal with in real life only exist in this first quadrant. Okay, and there we have the how to graph that word problem there. And so any spot in this triangle here, any coordinate, is actually a solution to this system. For example, I could hire 10 packing employees and 5 shipping and still be less than 20 total. So anywhere in here is a combination that works. Okay, one more type of problem here. This is graphing the absolute value inequalities. So I'm going to do this first one, and I want you guys to do this one. We've already kind of messed with these graphs, so we know how they shift. So this little 1 here is going to shift me up 1. Now if I totally forgot how to graph these, I can always go back and make a t-chart. So let's just do that real quick. I'm going to pick like -2, -1, 0, 1, and 2. When I plug these values in, -2 becomes +2, becomes 3. -1 becomes +1, becomes 2. 0 becomes 1, 1 becomes 2, and 2 becomes 3. Alright, so let's plot these points. Back 2 up 3, back 1 up 2, at 1, at 2, and there we go. So we got a little V, and sure enough, just like it did before, this little 1 out here has shifted the whole graph up 1 unit. Now I made a little mistake here. I don't know if you can see it, but my graph should have been dotted. So I'm going to go back in and just kind of draw little dotteds here so that you can tell that it should have been dotted. And it should have been dotted because I don't have an or equal to sign here. Now the last step is y is less than. Well, if y is less than, that means I'm going to shade below. There we go. I've graphed it. So give this next one a shot on your own. See what you come up with. I'll put the graph up in just a second. Okay, if you use a t-chart, you should have gotten some points right around here. But hopefully you saw that this -3 just shifts our v graph down 3 units. It's a solid line because we have an or equal sign, and the y is greater, so we shade above. And that is it. That's it for graphing inequalities. See you guys in the next video.